Hello, ladies and gentlemen. Today we are going to spend a day simplifying radicals and rationalizing the denominator. This first slide right here is a warm-up of the skills that we have worked on so far. So just as a quick review, remember what you are trying to do is you are trying to find two factors that you can break 72 up into, one of them being a perfect square. So the largest perfect square that goes into 72 is 36. So 36 times 2, then we give each one their own square root, and then we end up with 6 times the square root of 2. That would be our answer. When we have variables involved, we're looking for perfect squares, which are going to be even powers. And so the largest even power that I can break x to the fifth up into is x to the fourth times x to the first. And then again, I give each one, using the product property, their own square root, and this becomes x squared times the square root of x. Then we started working on the quotient property, and with that, if we can see that either the numerator or the denominator are perfect squares, we're just going to take the square root of each one separately. If we don't see that, we try to reduce the fraction first. So this would end up to be the square root of 24 over 3. But the square root of 24 still has a perfect square in there, 4. So I still have to keep going with simplifying, and this would become 4 times 6 over 3. And then again, giving each of those factors their own square root and take it individually using the product property, that gives me 2 square root of 6 over 3. That's my final answer. And then last but not least, the same thing kind of is true with this last question. You are going to take the square root of each one separately, which gives you the square root of 18 over this just x, because the square root of x squared is x. And then again, the square root of 18 still has a perfect square in it, so we have to separate that into the perfect square factor and the other factor so that we can take the square root of each individually using that product property, and that gives us 3 square root of 2 over x. So that's kind of a review of the skills that we've been worked on so far. Today we are going to rationalize the denominator, and this will be our last lesson before our test. So here are the steps for reminders about simplifying radicals. When it's in simplest radical form, you cannot have a factor under the square root, that's the radicand, that are a perfect square other than 1. So we just looked at this one. There is a perfect square that goes into 18, so it's not simplified. We'd break that up into 9 times 2, and then we would take the square root of each individually, and that gives us 3 square root of 2 is simplified. In number 2, we cannot have a fraction under the radical and have it be simplified. So we would take the square root of each of these individually. The problem in this one becomes now we have this answer, but we also, this is the last piece, we cannot have a radical in the denominator. And so that's what we have to take care of. We have to get rid of that radical on the bottom, and I'll show you how to do that. So it goes back to thinking about how many different ways you can write the number 1. Well, you can write 1 as 1 over 1, but 5 over 5 is also 1. Negative 2.2 over negative 2.2 is also 1. And x over x is also 1. So what we look at, if we have the square root of 3 over the square root of 3, that really, all of that still equals 1. So all of these equal 1. So what we're going to do is we're going to take that radical in the denominator and multiply over itself. So we're going to multiply by whatever the radical is that's in the denominator, because I'm really just multiplying by 1. So it says steps for rationalizing the denominator. I'm going to multiply the numerator and the denominator by the radical that is in the denominator. So whatever this square root is right here, whatever that is, you're going to multiply it by that over itself, because that really just has a value of 1. And so now what happens is this becomes 6 times the square root of 5 over, and then the square root of 5 times the square root of 5 is the square root of 25, which is just 5 again. So Any square root times itself is just the number under the radical. And that's how we simplify. And sometimes we have to like look at this fraction right here, look at this as a fraction and reduce it. This one can't be reduced, so we don't need to worry about it. So we're going to try a few of these, and then you're going to try some on your homework. So here's another example you can look through. You can pause the video to see that one as well. So on question number 1, what I'm going to multiply by is the square root of 13 over the square root of 13, because that has a value of 1. And then that gives me 8 square root of 13 over 13. That's simplified. Going down here to number, I'm just going to kind of do a few of these, and then you can look at the rest of the video or the answer notes for the rest of these. So I'm going to multiply number 3 by the square root of 6 over the square root of 6. And what that gives me then is it gives me 24 times the square root of 6 over 6. But if you look at this now as a fraction right here, that can be reduced. That 24 and 6 reduces to 4 over 1. So what this becomes then is it becomes 4 square root of 6 over 1, or just that answer right there. So there's your first two. So you always have to be looking for to see if that fraction can be reduced. If we look at a couple more here, they get a little bit more complicated. So it doesn't seem like they will be, but at times, but I'm going to multiply by the square root of 2 over the square root of 2. And then what happens is this becomes the square root of 3 times 2 under the same radical, like we were doing before, over 2. And so now this becomes the square root of 6 over 2. And what happens also sometimes is when you multiply these two together, sometimes you're going to get a number that needs to be simplified more because there's a perfect square that goes into it. In this case, there is no perfect square that goes into 6 besides 1, so that is our answer right here. Going down here or over here to number 6, we're going to multiply by the square root of 7 over the square root of 7. This is going to give us the square root of 2 times 7 over 7, or the square root of 14 over 7. That can't be simplified anymore because there is not a perfect square still under the radical. Question number 7. Okay, we can't reduce this fraction and there are no perfect squares, so I can't have a fraction under the radical, so I give them their own square root, which gives me the square root of 7 over the square root of 5. Now I have to get rid of the radical in the denominator, so I multiply by the square root of 5 over the square root of 5, and that gives me the square root of 7 times 5, or 35 over 5. And our last one I will work out here for you at this right now on this particular page is the square root of, let's see here, I got a bunch of different things here I need to get rid of. There we go. All right, so multiply by the square root of 5 over the square root of 5, which gives me the square root of 45. 13 times 5 is 45. So I get the square root of 45 over 5, but there is a perfect square that goes into 45. So this becomes 9 times 5 is 45. So this becomes, again, giving each their own square roots. The square root of 9 is 3. So this is going to become 3 square root of 5 over 5. All right, we got a couple more. Again, they get a little trickier as we go. There's different things that we have to apply. So we'll do a couple on this page and then let you work on your own. All right, so question number 9. You try it, see what we do. Pause the video, see if you can try that one. We're going to multiply by the square root of 2 over square root of 2, which gives us the square root of 12 over 2. But perfect square goes into 12, 4, so this becomes 4 times 3 over 2, giving them their own square roots. That becomes the square root of 4, which is 2, so I get 2 square root of 3 over 2. So you're going to find that when you multiply those together under the radical, you're often going to get a number that has a perfect square factor that you need to take care of. Not all the time, but let's have you try number 10. And start the video again when you're done. So, number 10, what you should be multiplying by is the square root of 3 over the square root of 3. That gives us the square root of 21 over 3. That one does not have a perfect square that goes into 21, so that one is simplified. And again, remember to always look at the fraction piece. Any numbers outside the radical on the top and the bottom need to be checked to see if they can be reduced. And let's go to number 11 here. So we're always multiplying by whatever this is over itself. And 16 times 3, if I multiply those back together under the same radical, that's going to give me the square root of 48 over 3. The square root of 48, there's 16. Well, actually, if I went back here and didn't multiply those together, the square root of 16 is already 4. But I didn't see that at first, so I know that 16 goes in there 3 times. So I'm kind of making some extra work for myself here, but it's okay. You can get there different ways. So this becomes the square root of 16, which is not 2, is 4, times the square root of 3 over 3. Number 12 looks harder, okay, but we follow the same process. Remember, when we have that number on the outside multiplied, that's just multiplication next to that square root. So I'm going to multiply by the square root of 5 over the square root of 5, which is going to give me 2 times the square root of 3 times 5, or 15 over 5. And nothing can be simplified more. There's no perfect square factor under the radical, there's no fraction under the radical, and there's no radical in the denominator. Those are the things that you need to always be looking for. So I'm going to host a Zoom session tomorrow. If you're interested, check the updates and join, and I will be happy to help you through some of your struggles, or you can certainly message or email me. Have a great day, everyone.